Hello and welcome back. Let's talk a bit about how we can write good code and what are the best practices for writing good code. First of all, as with always, why should we bother? After all, the code is just for me, right? I would just want to finish this assignment. I need to get on with my research topic. I don't have the time right now to write good code. It's just a quick and dirty proof of concept or any other excuse you might have. Actually, I've used the same excuses in the past myself. However, writing good code is really a good idea because code typically lives longer than we anticipated. A quick hack becomes the cornerstone of our project. It's also much easier to maintain by a team, or if you work in a research group, if you have well-developed code, and it's easier to understand, not just for others but also for yourself if you have well-structured code. You also run less into risk of having bugs, and it's easier to reuse code across projects, for example, if it's well written, documented and tested. You will also want to anticipate any unexpected behavior and make sure that the code actually does what you think it does. So writing good code is actually a journey. It's not something that you can say, oh, today I'll write good code and then you're done with it. You really need to think about how you do this. The most basic thing you do is actually using descriptive variables, so avoid short variables that are just like a letter or a few letters, because a few days down the road you can't really remember what you wanted to say here. Then you use, for example, clean code principles and organize your code accordingly. You can use then some other methods like kiss and dry. We'll come to that in a minute. One other thing that we need to think about is code documentation. So we can, for example, use doc strings and swings to auto-document our code and have code tests, both unit and integration tests, to make sure that the functionality we implement is actually working. And finally, especially if we work in a team, we should really do code reviews where we sit together and discuss what the code does and how it can be implemented better. If you, for example, work in the commercial world, in a team, in software development teams, you will find that all of these principles will have to be followed in order for the code to be accepted to go into the repository. So what are some general principles? As we just said, we use descriptive variable names, and the name of the variable should really reflect its function. So for example, we have a function called Fibonacci instead of f. We should also have a clean visual style that affects the code layout, the indents and the naming conventions. And there's a general Python standard for this, which is called PEP8. Of course, other companies and teams have extended this. There's a general recommendation from Google that is used internally by them. And as a hint, you should use proper tools in your development environment. So there are a number of them. You should use a combination that suits you best. That also makes it easier because these tools integrated in your IDE will auto-format things directly, so you need to spend less time doing it manually. We've come across these acronyms before, and there are some good principles to live by. KISS stands for Keep It Simple, Stupid. That means we should avoid unnecessary complexity and keep the code as simple as we can. We should also adhere to DRY, which means to don't repeat yourself. Code should only do one thing and don't copy and paste it around. Rather, refactor the code if you need to reuse it. Put it into suitable functions and libraries and use those again. That also means that you only have one piece of code for one functionality, and if you do discover a bug, you don't need to fix it in several places. Yagni, you aren't gonna need it again. Remove what isn't necessary and favor readability over conciseness. If in doubt, write more explicit code rather than cryptic one-liner. Write for understandable code first and then, for example, use profiling tools to optimize later if this is really necessary. Documentation and tests are a key part of good code. So the documentation explains what the code does, explains how it's used and what the inputs and the outputs are. There are tools to auto-generate the web pages, like for example swings, and this helps users and yourself to use the code And the tests make sure that the code does what it should. The lowest level is unit test, where we test the individual functionality of, for example, a Python function. The integration test tests the interplay between several parts of the software, and the system test tests the whole thing.